Hello and welcome back to part 4 of velocity and acceleration lesson. So in part 3 we analyzed the motion of an object that is moving away or towards a starting point or a reference point. By reference points we mean position equals 0. And now we are going to take a look at an application question. Please recall that an object is moving away from the starting point if the product ST/VT is positive, which means both V and S are positive or negative or have the same sign, and an object is moving towards the initial point or the point of reference, if the product ST/VT is negative, which means V and S are opposite in sign. So here we are again, example 3. Says that the position function of a cheetah moving on level ground in a straight line, chasing after prey, is given by this cubic equation. T is measured in seconds and S is measured in meters. We have to find the times when the distance from the initial position is 0, which means that we have to find the time when ST equals 0. So we'll grab this same equation and we'll make ST equals 0 equals T to the power 3 minus 15T squared plus 63T. So that would be T squared minus 15T plus 63. Factor a bit more. We have a quadratic. It's a simple form of quadratic, so the coefficient of t squared is 1, which means that we are starting with t in both factors. And then we have to find two numbers that multiply to positive 63 and add to negative 15, so they must both be negative. So negative 9 and negative 6 will fit perfectly in here. Make each factor equal to 0. And that will give us time equals 0, time equals 9, and time equals 6 seconds. So these are the times when cheetah's position from the point of reference or the starting point is 0. Now we have to determine the intervals when ST is positive and when ST is negative. You can do it in various ways. I'm going to go over the chart way. So I usually like to start by drawing a straight line, and this will represent the number line where we place the values of t. And the time t will start at 0 seconds, and then we have to place the other values of t, 9 and 6 seconds. We need to put the numbers in order, but they don't have to be scaled. Now, on the left side here, we will list the factors. So the factors we had were t minus 9, and t minus 6. And we will reserve the last column for the sign of ST, which is basically the product of the three. So at time equals 0, t will be 0. So that means that for positive values of t, the factor t will have a positive value. T minus 9 will be 0 at 9 seconds. And t minus 6 will be 0 at 6 seconds. So whenever either factor is 0, then the product will be 0 as well. T minus 9 will be negative to the left of its 0, positive to its right. T minus 6 will be negative for values of t between 0 and 6. And you can use a testing value there. And it will be positive for any value of t bigger than 6. So 7 minus 6, 100 minus 6. All right. And now we will marry all the signs. Plus, minus, minus. The product will be positive. Here will be negative, and here will be positive again. So we will say that ST is going to be positive. For the values of t starting from 0 to 6 seconds and from 9 and from 9 to infinity, assuming that the cheetah will have a very, very long lifespan. So ST will be negative if the value of t is anywhere between 6 and 9 seconds. Now we need to determine the velocity. Remember, velocity is the derivative of position. So we'll write Vt equals S prime t. So St is right here. We're differentiating that. So we have 3t squared minus 30t plus 63. So velocity at any time will be 3t squared minus 30t plus 63. The next question is asking, when has a cheetah momentarily stopped? Momentarily stopped means that Vt equals 0. So we'll say 0 equals 3. So we're using the velocity equation, right? Times t squared minus 30t plus 63. I would reduce the coefficients if possible, so that's easier for me to factor and then solve the equation. So this will be transformed to 0 equals t squared minus 10t plus 21. In factored form, we'll have t minus 3, t minus 7. So therefore, we're going to say that the cheetah has momentarily stopped at time equals 3 seconds and time equals 7 seconds. Now we have to find the intervals where Vt is positive and where Vt is negative. In other words, we have to study the sign of Vt. So remember, we have the equation of Vt in factored form right here, and we have the zeros as well. You can create the chart, obviously. And let me make this super straight. And the time starts at 0. It can continue to infinity, hopefully. And we have to place the zeros in order, so 3 and 7. And here go the two factors, t minus 3, t minus 7. And here is the sign of Vt. So here we go again. We're going to say that 0 here, 0 for Vt. This is very interesting and clever. Here we go. And we have time equals 0, 0 here. So negative, positive, negative, negative, positive. So the product will be a positive, a negative, a positive. So we'll say that Vt is positive in the time interval from 0 to 3 seconds and in the time interval from 7 to infinity. and Vt is negative in the time interval between 3 and 7 seconds. Now, this is the exciting part. We have to determine when the theta is moving away and when it's moving towards the starting point. Remember, in order to do this, we have to consider the sign of St and Vt. So guess what? We are going to have to draw a long, long line. That would represent a line for the time. So we're going to start with time 0 seconds. And on the side in here, we will start with the sign of St. And then we'll continue with the sign of Vt. And at the bottom, we are going to write the sign of the product Vt St, or St Vt, doesn't really matter. And then we are going to reserve one last column for deciding whether the object is moving away or towards. So that's where the decision is made. So in other words, describe the motion, right? By using these two words. So how do we do this? So in order to do this, we are going to place on the number line all the values of t when St was 0. And all the values of Vt, or all the values of the time, or the moments when Vt was 0. So let's take a look at the first chart. We said that St was 0 at 0, 6, and 9. So these are important points on the graph. So I'm going to write them down somewhere, 0, 6, and 9. And for velocity, the key values are 0, 3, and 7. So we don't have to write 0 again, 3, and 7. So these are going to be the key values of time. So they must be placed on the horizontal axis that represents time. Let's make them green, actually. Okay, right here. And now we'll place them in order. So 0 is over there. The next number after 0 is 3. The next number is 6. The next one is 7. And the last one is 9. So because we are studying the sign of both position and velocity, we have to place all of their zeros on the number line that represents the values of t. And now we are going to create the chart, or build the chart, or even better, fill it in with the information. Now remember, 0, 6, and 9 are the zeros of St. So St will be 0, at 6, and at 9 seconds. 3 and 7 are the zeros of Vt. Okay, so whenever either one is 0, then the product will become 0. So these are all zeros for the product Vt St. And obviously this is a 0 as well. Okay, and now we are going to indicate what the sign of St is in the intervals, okay, of time that we have created. So we have broken down the time into these intervals because in each interval, position and velocity will have a unique sign. So remember that for velocity, we have the zeros at 0, 6, and 9. And we said that from 0 to 6, velocity is positive, 6 to 9 negative, and then positive. So we'll say 0 to 6 positive for velocity, 6 to 9 negative, and 9 to infinity, it became positive again. Okay. For velocity, on the other hand, here is velocity. The key values are at 0, 3, and 7. We say that between 0 and 3 seconds, that's positive, and 7 and infinity, positive. So we'll say sine of ft is positive here, and positive after 7. Between 3 and 7, velocity is negative, between 3 and 7 seconds. So now we have the sine of st, or the sines of st and vt, defined for any moment in this time, in these time intervals. All we have to do is multiply them. So we'll say that plus and plus will make a plus here, and then a minus, a plus, a minus, a plus. Wherever we see a product that is positive, that means that the object is moving away from the starting point. Whenever we see that the product is negative, that means that the object is moving towards the starting point. Okay, so it is very important that we learn and understand the meaning of this chart and how it works, how we build it. And I hope that this makes sense and it helps you visualize and analyze the motion of the object with a lot of precision. Now, the next topic is analyzing whether an object is speeding up or slowing down. So I will see you in the next video. Thank you for listening.